Areas of triangles and quadrilaterals with a review of perimeter. Our objectives for this section, 1, to find the areas of squares, rectangles, parallelograms, and triangles. And 2, find the areas of trapezoids, rhombuses, and kites. So we're going to start off with the area congruence postulate. This postulate says if two polygons are congruent, then their areas are the same. Next is the area addition postulate, and this postulate is going to allow us to find the area of the area of figures that are not nice shaped convex polygons. So the area addition postulate says that the area of a region is the sum of the areas of its non-overlapping parts. And we're going to use this in some examples on the next page, so you'll see exactly what we're talking about. All right, so some area formulas. Reminder that for a square, the area of a square is, is the square of its side length. Sorry, the area of a square is the square of its side lengths. So if we've got a square over here, we know it's a square because all of the sides are congruent and all of the angles are right angles. So if we have side length S, that means every side length is S. And so area, length times width, is S times S, or S squared. Area of a rectangle. So in a rectangle, again, we've got right angles at all of our corners, but this time we've got two pairs of congruent sides. We've got our shorter side congruent, and then we've got our longer sides congruent. So the area of a rectangle is the product of its base and its height. And it doesn't really matter which one you say is the base, which one's the height. Just know you will multiply them together to get your area. Alright, so the area of a parallelogram. For our parallelogram, a parallelogram has two pairs of parallel sides. Now when we're looking for the height of a parallelogram, basically what it is you take a pair of the parallel sides, and the height is going to be the perpendicular length between those two parallel sides. Sometimes it might show up outside of the figure, like so. But you're looking for that right angle sign to show that it is the height. And we could have also done, we could have used these as our base and then drawn a height through here. You're just basically looking for this right angle sign to show you where your height is. And then area of a triangle. The area of a triangle is half the product of a base and its corresponding height. So a triangle is going to have, basically, it could have one of three heights. The height is just a perpendicular line dropped from a vertex to the sides opposite it. So this is a height here, and then this would be the base with the corresponding height. We could also have a height dropped from this vertex over here, and that would be our height, our base. Or we could have had a height dropped here, and then that would be our base. So basically, again, you're looking for that right angle sign to show you that that's your height. And depending on the triangle, it could be inside the triangle, it could be outside the triangle. Just like with parallelogram, it could be inside or outside. Example 1. It says to find the area of the parallelogram. Alright, so in our picture right here, here's our right angle. So we know this is our height. And this is our base. We do have this 4.5 inches over here. We don't need it. It's basically extra information. Alright, so area of a parallelogram is base times height. So we're just going to do 4 inches times 5 inches, and 4 times 5 is 20. Now when we're talking about area, units of measurement are squared. Area is units squared. So in this case, our area is 20 inches squared. All right, example 1, part B. All right, so again, we're looking for the area of this rectangle, or parallelogram, sorry. Again, here's our right angle, so that tells us where our base and height is. Now, we don't need the height from here to the right angle. We just need the base. We just need the base that's actually part of the parallelogram. So our base is going to be that 2 centimeters. And our height is outside of our parallelogram because that's the only way we can draw a perpendicular line down here. So our base is 3.5 centimeters. Or I'm sorry, our height, 3.5 centimeters. Again, we've got extra information, so we don't need that. So our area, base times height, 2 centimeters times 3.5 centimeters. I believe that's 7 centimeters squared. All right, example 2. What is the area of a parallelogram with base length 12 meters and height 9 meters? All right, so we know our base is 12 meters, our height 9 meters, and so all we do is multiply them to get our area. So area is 12 meters times 9 meters. That's a little too big for my brain to do on its own. So 12 times 9 is 108. So the area, 108 meters squared. Example 3. To make 2 triangular sails like the ones shown, how many square feet of material are needed? Now, in case you can't really tell from the picture, it right here says 4 yards. And we're told down here our base is 13 feet. So you'll notice one of our units of measurement is yards, the other is feet. So we're going to have to make sure we get the same measurement, units of measurement, before we can multiply them together. So easiest thing to do, change yards into feet. So there are, let's see, we got 4 yards. There's 3 feet in a yard. So if we multiply those together, yards are going to divide out, and we got 12 feet. So that is our, let's see, that's our height. Our base is 13 feet. So now that we have both measurements in feet, we can plug it into our formula and get our answer. So remember, for a triangle, it's 1/2 base times height. So 1/2, 13 times 12. We can plug that into our calculator. So I use 0.5 for 1/2. You could use the fraction button and do 1/2 if you like, but 0.5 is the same as 1/2. So 1/2, our base was 13 feet. Our height was 12 feet. So 78. So our area is 78 feet squared. So they'll need 78 square feet of material to make those two sails in the picture. All right, number 4. What is the area of the triangle shown? So this time we have a right triangle. So our base and our height are actually parts of the legs of our triangle. So in this one, it doesn't matter which one we say is our base, which one's our height, but again, you'll notice this is feet, 1 foot, and that's 5 inches. So we know there's 12 inches in a foot, so that's the same as 12 inches. So we can say, let's see, we'll say our height is 5 inches, and our base is 12 inches. And so again, plug it into your formula. 1/2 base is 12 inches, height 5 inches. Plug that in. I believe it's 30, but let's double check. So 0.5 times 12 times 5 is 30. So 30 inches squared. So the area of our triangle is 30 inches squared. What's the area of the triangle shown? So this time our height is outside of our triangle. Now we do not need this entire length to figure out the base for our triangle. We just need the part of the actual triangle. So our base is going to be 2 feet. Our height, we know from our right angle sign here, is this. So 3 feet is our height. They're both in feet, so we don't have to do any sort of converting of measurements, so that's good. So we're just going to plug that into our formula. Area is 1/2 base times height. Let's see, half of 2 is 1, 1 times 3 is 3, so our area, 3 feet squared. Example 6, here's where our review of perimeter comes in. It says to find the perimeter of the room shown. So we've got ourselves a nice little irregular figure right here. And we can use some context clues to try and figure out what these two missing side lengths are right here. Let's see, looking at this side length, we know the whole entire length on the bottom is 15 feet. Now this part up here is 9. So to get this distance, we're just going to do 15 minus 9, which is 6 feet. Now for this part, this little part right here, we know the whole entire length is 10 feet. And we know that this part's 7, so this little part has to be 3. And then perimeter, remember, you just add up all your sides. So it'll be, I'll start up here, 9 feet plus 10 feet plus 15 feet plus 7 feet plus 6 feet plus 3 feet. And you just add all your sides together. That's going to give you your perimeter. So let's see. We've got 9 plus 10 plus 15 plus 7 plus 6 plus 3 plus 9 is 59. So our perimeter, 59 feet. Now remember, when we're doing perimeter, it's just 59 feet for our units. It would only be squared if we were doing area. All right, example 7. Again, we're doing perimeter. We're missing the side lengths for this little part right here. We know the entire length here is 20 meters long. From here to here is 15, so this part has to be 5. We know this entire length is 31 meters. This little piece of it is 6, so 31 minus 6 is 25, so this part is 25 meters. So to get our perimeter, we're just going to add them all up. So 6 meters plus 20 meters plus 31 meters plus 15 plus 25 plus 5. Okay, just double checking I got them all. Alright, so add them up. We got 6 plus 20 plus 31 plus 15 plus 25 plus 5 is 102. So our perimeter, 102 feet. All right, so for example 8, this is where our area addition postulate is going to come up. So we know how to find the area of a rectangle, base times height. So basically what we're going to do is we're going to take our rectangle, or our figure here, and break it up into 2 different rectangles. And the area addition postulate says the area for the entire figure will just be those 2 areas together. So we can either drop a line here and make 2 rectangles, or we can drop a line here and make a square and a rectangle. Either way, you should get the same answer. So let's see, we got to find some missing lengths. If this whole length is 12 feet and this part's 4, that means that part has to be 8. And then if this part is 8 feet and this is 5, then this missing part is 3 feet. Okay, so I think I'm going to drop my line right here, and I've got 2 rectangles. So I'm going to start by finding the area of rectangle 1. So for area of rectangle 1, base times height, so 4 feet times 8 feet. And 4 times 8 is 32 feet squared. Since we're talking about area, our units are squared because we got feet times feet, so feet squared. All right, so the area of rectangle 2, we've got a base of 8, height of 5. So 8 feet times 5 feet is 40 feet squared. And so the area addition postulate says if we add those areas together, it'll give us the area of the entire figure. So area is 32 feet squared plus 40 feet squared, which is 72 feet squared. Now real quick, let's look at what would have happened if we had done the other way. If we had drawn our line right here, we would have had a square. It wouldn't have been a square, it would have been a rectangle. We would have had a rectangle here, 4 times 12, 4 times 3 is 12. And then we would have had a rectangle here, 5 times 12 is 60. So 60 plus 12 is 72. So we would have gotten the same area regardless of where we had drawn our rectangles. All right, example 9. Find the area of the region. Again, it doesn't matter which way we draw our rectangles. I'm going to drop my line this way. All right. So we got a square, 18 meters, 18 meters. We know this whole length here is 24 meters. So this part, let's see, 24 minus 18 is 6. So that's 6 meters. All right, so 1, 2. Area of rectangle 1 is 12 meters times 6 meters. I think that's 72, but let's double check. Yeah, 72. So 72 meters squared. Area of rectangle 2, we got 18 times 18. So 18 squared is 324. So that area is 324 meters squared. So the area of the entire figure, 72 meters squared, plus 324 meters squared, which is, let's see, 396 meters squared. So that's the area of our figure, our entire irregular figure. All right. So now let's move on to trapezoids, rhombuses, and kites. All right, so first let's talk about, actually real quick, you'll notice in this one I did it this way instead of this way, and I still ended up with 396 meters squared. So you get the same thing. All right, height of a trapezoid. The height of a trapezoid is the perpendicular distance between the bases. And so to find the area of a trapezoid, I've got a little trapezoid drawn here. Your bases, a trapezoid has a pair of parallel lines, and then these lines here are not parallel. So that's what makes it a trapezoid. And so we call the parallel lines base 1 and base 2. And so the height is a perpendicular line between those two bases. And so the area of a trapezoid is half the product of the height and the sum of the bases. So A is equal to 1/2 times H, and then parentheses B1 plus B2. Okay, our last formula is area of a rhombus or a kite. So a rhombus is a four-sided figure where all the sides are congruent, but the angles are not. So it's not a square, but it does have all four sides congruent. It has two diagonals, D1 and D2. And then a kite has two pairs of congruent sides. It's got these sides here, which are congruent, and then these sides here, which are congruent. And again, we've got two different diagonals. We have one here and one here. So the formula, the area of a rhombus or kite is half the product of the lengths of its diagonals. So the area is 1/2 times D1 times D2. Okay, so example 10, we're finding the area of the trapezoid shown. Basically, we just need to figure out, plug things into our formula. Our base 1, we can say, is 21 inches. Base 2 is 38 inches. And the height is 16 inches. And so the formula, if you don't remember, is 1/2 times the height, so 16, and then the sum of the bases, so 21 plus 38. And this you can plug straight into your calculator. Again, I'll use 0.5 instead of the fraction for 1/2. So 0.5 times 16 times, and then in parentheses, make sure when you're adding the bases in your calculator that you put them in parentheses. And then hit enter, and you get 472. So our area is 472. And again, we're talking about area, so it's units squared. So since we're working with inches, it's going to be inches squared. All right. Find the area of the trapezoid shown. Okay. So we've got, this is a little bit of a different thing we got to do here because we're not given all of our sides. We do know our base 1 here is 6 feet. And then our base 2, we've got this part 6 feet. And then this part's 3, so 6 plus 3 is 9 feet. So base 2 is 9 feet. Now we don't know our height, but we're given the information to find it because we've got a right triangle right here. So we can use, I'll put H for height. We can use Pythagorean theorem to figure out our missing height. So let's see, the longest side, our hypotenuse is 5. Okay, so we got 3 squared plus h squared equals 5 squared. So 3 squared is 9. 5 squared is 25. Subtract 9 on each side. And we get h squared is, I believe it's 16, but let me double check. Yep, 16. Square root each side. And h is 4. Alright, so we know our height now. The formula again is 1/2, formula for area, 1/2 height, which we just found out was 4. Base 1 is 6 feet, base 2, 9 feet. So our area is going to be 1/2 of 4 times the quantity 6 plus 9. Times 4 times 6 plus 9. And we get 30. So our area of our trapezoid, 30. And it's feet squared since we're talking about area. Alright, number 12. We got a trapezoid again. This time we are missing our height still. So we do have to do a little bit of calculating beforehand. Let's see, I'm going to drop down height. This time we've got a 30, 60, 90 triangle. So hopefully you remember, in a 30, 60, 90 triangle, you've got your short side, your long side, and your hypotenuse. So we're given our hypotenuse is 8 feet, and our 60-degree angle's here. So our longer leg is our height, so that's what we're looking for. So hopefully you remember, if you're given the if you're given the hypotenuse in a 30, 60, 90 triangle, first thing you find is your short side, divide by 2, so 8 divided by 2 is 4. And then the longer side is the shorter side times the square root of 3. So h is going to be 4 square root 3. So that's our height. Okay, so now we know we got a base here. In our picture base, we'll say that's base 1 is 15. Base 2, we know this part is 4, so the rest of it, which is base 2, is going to be 15 minus 4, which is 11. So base 2 is 11. So we're going to plug that into our formula. Area is 1/2 base, which was 4 square root 3. 15 plus 11. Now I'm not sure whether they're going to want to give you, in the homework assignment, whether they're going to want an exact solution or a decimal approximation. So let's figure out both. 0.5 times 4 square root 3. It gives us, I'm going to do it. I want it to give me an exact answer, so square root is 2 square root 3. And then we're going to multiply, let's see, what's 15 plus 11 is 26. So 2 square roots of 3 times 26 is 52 square root 3. So that is your exact solution, and it'd be feet squared. If they want the approximation, remember you just hit this little button down here above enter, and it'll turn your approximation or your exact solution into an approximation. So 90.1, we'll round it up to 90.1 feet squared. So depending on which one they give you. I believe if you just type in your answer like this into your calculator, it'll give you the approximate solution. So keep that in mind. Alright, so now we're on to kites. Find the area of the kite shown. So again, area of a kite is 1/2 times diagonal 1 times diagonal 2. So we'll say this is diagonal 1, which is 3 plus 3, or 6 meters. Diagonal 2, 2 plus 5 is 7 meters. So the area, 1/2, 6 meters times 7 meters, which is, let's see, half of 6 is 3. 3 times 7 is 21 meters squared. Example 14. Find the area of a kite with diagonals that are 12 inches and 9 inches long. So we can say diameter 1 is 12 inches. Not diameter, diagonal. Diagonal 2 is 9 inches. Plug those straight into your formula. Area is 1/2 diagonal 1 times diagonal 2, which is going to be 6, let's see, half of 12 is 6. 6 times 9 is 54. Just want to double check. 0.5 times 12 times 9. Yeah, 54. 54 inches squared. Alright. So now we're going to do some area of rhombuses. Is it rhombi? I don't know. But one property of rhombuses, we never got to properties of quadrilaterals. That was going to be our next section before we all got locked down. And we would have continued with that, but I have to do the same thing that Miss Reeves is doing with her classes, so that's why we had to skip quadrilaterals. But anyways, one property of rhombuses that's very important to remember when solving these is that your diagonals bisect each other. So those are the same, and these are the same, which means diagonal 1, both sides are 20 feet, so 20 plus 20 is 40. And for the other diagonal, we got 30 plus 30, which is 60. And so we use the same formula for area of a rhombus as we did for a kite. So 1/2 times diagonal 1, which is 40 feet. I dropped my pen. Times diagonal 2, which is 60 feet. 0.5 times 40 times 60 is 1920. So our area is 1,920 feet squared. All right, and then last one, another important property of rhombuses is that the diagonals are perpendicular bisectors. So they are going to intersect at a right angle. This is the same as this, so this is also 8 inches. Now, we don't know anything about our second diagonal, but we do know this is 10. And we got a right triangle. So we can use Pythagorean theorem to find our other missing diagonal, or part of our other missing diagonal. So this would be x squared plus 8 squared equals 10 squared. 8 squared is 64. 10 squared is 100. Subtract 64 on each side, and we get x squared equals 36. Square root, and x is 6. So this is 6, and that is 6. So diagonal 1 we know is 8 plus 8, which is 16. Diagonal 2, we just figured out, was 6 and 6, which is 12. And so our area is going to be 1/2 16 times 12. Oops. 0.5 times 16 times 12 is 96. So our area, 96, let's see, that's inches squared. So there you go. So if you're missing, when you're doing these problems, if you're missing any pieces of information, then they've either given you enough information to do Pythagorean theorem to find what's missing, or they've given you enough information to do special right triangles. So remember, in a 45, 45, 90 triangle, your legs are the same length, and then the hypotenuse is the square root of 2 times the leg length. And then in a 30, 60, 90 triangle, your shorter leg is, you got a shorter leg. The longer leg is the shorter leg times the square root of 3. And the hypotenuse is 2 times the shorter leg. So that should be enough to help you find any missing pieces of information in your figures if you're missing something. Remember, I have office hours every day, 9:30 to 10 a.m. I'll post the Zoom link in my Google Classrooms for you. And you can also contact me through Snapchat if you have my Snapchat, or through email. I get notifications for that throughout the day. So please let me know if you have any questions.